In this lab assignment, you will develop both a lexical analyzer and a syntax analyzer. The lexical analysis phase, also known as scanning, is the first stage of a compiler. It processes the source program as a stream of characters and organizes them into meaningful units called lexemes. For each identified lexeme, the lexical analyzer generates a corresponding token, which is then passed to the syntax analysis phase. As part of this lab, while constructing the lexical analyzer, you will output information indicating which token has been generated for each lexeme. The line numbers has also be printed in your output file. We will construct a scanner for a subset of C language, so the input will be a text file containing a C source program. The task will be performed using a tool named Fast Lexical Analyzer Generator, in short FLEX, which is a popular tool for generating scanners. Now for generating tokens for the lexemes, you will need to match the patterns with the lexemes. If the lexeme match with the pattern, then you will execute the corresponding action, which is basically printing the token generation message with the lexeme and with the line number information, and you have to return the token to the parser. There will be different kind of lexemes in your code. For example, keywords, constants, operators and punctuators, identifiers. Along with this, you have to capture the white spaces and new lines from the input file. For new lines, as we were printing the line numbers, you have to count the number of lines in the lex file using the variable lines. And for white spaces, no actions are needed. For lexemes like identifiers, it will return a token named ID and pass its symbol and type using a symbol info pointer as the attribute of the token. On the other hand, in the case of semicolons, it will only return the token as the parser does not need any more information. You can implement this by redefining the type of YYLVAL in the parser and associating YYLVAL with the new type in the scanner. You also have to write the regular expressions for identifiers, integer numbers, floating numbers, white spaces, and new line. Now comes the second part of the assignment, where you have to write the grammars and their corresponding actions on your YAG file. Our chosen subset of C language has the following characteristics. There can be multiple functions. No two functions will have the same name. There will be no pre-processing directives like include or define. Variables can be declared at suitable places inside a function. Variables can also be declared in the global scope. Precedence and associativity rules are as per standard, although we will ignore consecutive logical operators or consecutive relational operators like A and B and C. No break statement and switch case statement will be used. At first, you have to introduce all the tokens which will be returned by your lexer. Then you have to incorporate the grammar given in the file lab1 syntax analyzer grammar.pdf in your YAG file. Use a symbol info pointer to pass information from lexical analyzer to parser when needed. When a grammar matches the input from the C code, it should print the matching rule in the correct order in an output file. For each grammar rule matched with some portion of the code, print the rule along with the relevant portion of the code. Some rules are done for you, but the rest of the rules mentioned in the Lab1C Syntax Analyzer Grammar PDF have to be completed in the similar way. Lastly, in your main method, You will have to throw error if the value of argc is not 2, and after the parsing is complete, you have to print total number of lines found on your code.